Alright, and welcome to Analyzing Quadratics, Level 1. Now, in example 1, we have f of x equals x squared plus 6x minus 16. And what we're going to do is we're actually going to analyze everything. We're going to find the solutions, we're going to find the zeros, we're going to find the vertex, whether it's a maximum or a minimum. We're going to find the domain, the range, we're going to find everything. And the best place to start is, let's call this part A. We want to start with our solutions. And remember, our solutions have several other names. We could also call our solutions our x-intercepts. We could call them our roots, or we could call them our zeros. All of these things mean the same thing. And in order to figure out what these are, what we want to do is we always want to set f of x equal to 0. So our 0 equals x squared plus 6x minus 16. Alright? And then from there, since my a value is equal to 1, I know I can probably factor this. I bring my negative 16 over here, and I break down all the factors of 16. 1 and 16, 2 and 8, and 4 and 4. And since we have this negative right here, this indicates to me that on some level I had a negative times a positive. So we're not asking what two numbers add to be our b term, we're asking what two numbers subtract to be our b term. And we can say, okay, if I want a positive 6, I would have to do 8 minus 2. Alright, or negative 2 plus 8 is equal to positive 6. Notice that if I had done positive 16 minus 1, or negative 1 plus 16, that would have been 15. That's wrong. And of course, if I had done 4 minus 4, that would be 0, and that too is wrong. 6 is what we're looking for. Two numbers that multiply to be negative 16, but combine to be our middle term, positive 6. So, I know that x squared breaks down into x times x, and my two values that I was looking for would be negative 2 and positive 8. Okay, now from here, what we want to do is solve for x. And we do this by setting both of our factors, x minus 2 equal to 0, right? Because anything times 0 would get us to 0. Or x plus 8 is equal to 0. Now in both of these cases, I want to solve for x. So I can add 2, I can add 2. We see x is equal to a positive 2. And here I can subtract 8, and x is equal to negative 8. And those are in fact my solutions. And I'm going to write that down here. My solutions are x equals 2, and negative 8. Alright, let's move on to our next thing that we have to find, which is the vertex. We're going to find the vertex. Okay, for part B, we know that we need to find our vertex. We're going to do this by completing the square. Now, in order to do this, I go ahead and I write f of x is equal to x squared plus 6x. And remember, I need a perfect constant, so I push my minus 16 off to the side. From here, I always take my b term and divide it by 2 and square it. In this case, my b term is 6. So I have 6 divided by 2 squared. We all know that 6 divided by 2 is 3 squared, and 3 squared is positive 9. So in that space I put positive 9, and to balance out a positive 9 I need a negative 9. At this point I write f of x is equal to, I want to write this as a perfect square, so I say okay, x plus or minus some number squared, and I'm looking for the same number that will add up to be 6 and multiply to be 9, and it's always half of your b term. 6 divided by 2 is 3. And 3 times 3 is 9. That's how you can test out if you have the right number. Now from here, negative 16 minus 9 is negative 25. And this actually allows me to solve for my vertex. I know that whatever value I see over here is always going to be my y value. So I have a negative 25 for my y value. However, I always have to set my grouping equal to 0. So I have x plus 3 is equal to 0. And I can subtract 3 from both sides. and x is equal to negative 3. Alright, at this point, pause the video, finish taking notes, and I'm going to clean this up for you. Alright, let's take our two pieces of information. We have our vertex at negative 3, negative 25. I know that negative 3 goes to the left, and I'll just write negative 3. And negative 25 goes down, and I'll just write one tick mark that says negative 25. Now let's put our vertex. Now I always ask myself, does my quadratic function open up or down? Since our x squared value is a positive, I know that's going to open up. And the question becomes, where does it open up? And it actually opens up at over here. Let's use some different values. It opens up over here at positive 2 and at negative 8. And I'll put points right there, and I see that my quadratic looks like that. Now, this allows me to do some pretty cool things. So, let's first talk about our vertex. I know that my x value of my vertex is going to be my axis of symmetry. So, I know that that is x equals negative 3. And we can even see that here because negative 3 splits the vertex in half. So I have my axis of symmetry. I also see that this is at the bottom, it is a minimum. So we have a minimum at negative 25. That is my lowest point. Okay. Now I want you to pause the video, and then we're going to tackle the very last thing, which is going to be our domain and our range. My domain asks the question, in the x direction, how far does my graph go? Notice that my graph is going forever to the left, going towards negative infinity, and my graph is getting wider and wider and wider, aka going towards positive infinity. And so we would say our domain is all real numbers. Pretty easy. You can even get fancy and write the all real number symbol. But our range is a little bit different. For our range, we ask, how low does this go? And this goes as low as our minimum of negative 25. So I say that my range is y such that y, and I'm going to take my minimum value, which is negative 25, and I have to ask the question, is every value here bigger than negative 25, or is every value here smaller than negative 25? And since this is going up, since every value is above the negative 25, I say y is greater than or equal to negative 25. Alright, I hope this was helpful, and I'll see y'all in our level 2 video.